Hi everyone, I hope you have joined the session. In case you have and if you can hear me, please mention a yes in the chat section so that I know you people are here. Okay, so anyway, since it's 6 p.m. already, we'll be starting the session off. So today's session is going to be interesting, really interesting, because this actually forms the crux of data science. So we'll be trying to understand what exactly is data science, and we'll be trying to appreciate a few things in today's session. Okay, apart from dealing with the obvious part, which is exploratory data analysis, as I already mentioned in the emails. So, what is data science? We already went through this in the last session, right? So it's more about understanding data, building a relationship with data to figure things out, derive insights to influence business decisions, right? Last time we took the example of Snapchat. Let me just give you another example of how data science actually works, and one key aspect in which it's helped us at Vidya. So about 2 months back, we started something called the Vidya Premier League, and in the Vidya Premier League, towards the end, I mean, like once everything was done, we had about 2,500 registrations in total, uh, which was a huge number. But then initially, what we realized was that out of the first 100 people who actually came onto our website to register, almost 80% of them didn't register. Okay, and then luckily we were collecting all this data. We were trying to see how many people actually came onto the website, how many people actually registered, how many people dropped out. So we were trying to understand these metrics, and we were, we had a pipeline to actually calculate them. Luckily, in this case, since we did have a pipeline, since we did have data, we went back through the data. And after 1 hour, we realized, okay, fine, we have only 20 people who have registered, and this is not right. I mean, something seems wrong. And that's when we realized that one major issue was that half the people who were coming, in fact, more than half the people who were coming to register for the Vidya Premier League, uh, did not have an account on Vidya. So the current registration process that we adopted, it made sure that people could register on Vidya's people could register for the Vidya Premier League if and only if they were already signed in. So since people weren't signed in, they found it really difficult. I mean, like not difficult, but then obviously we as people are always lazy, right? So we don't really want to spend a lot of time to actually get something, even if it actually adds value to our profiles or to our lives, our careers. So we realized, okay, fine, since this is the problem, let's actually tweak this out. So we decided to make the uh, registration process completely offline for anyone. So in the offline in the sense, like people weren't required to be signed in. So even if you were signed out, no issues at all. You could still register and then you could create an account. And that turned out to be a huge thing for us because, I mean, from going, so we literally burst from 20 registrations in the first 1 hour to about 600 registrations in the next 1 hour. That's the kind of impact this particular decision made, and that is the reason why data science is considered so important, because it's not just about coming up with insights, but then if you notice in the example, it's about what you could possibly do with those insights, right? The insight in the example that I just said was that the drop rate was really high. People weren't registering. So I mean, like almost 80% drop rate. People came onto our platform because they were interested to register, but then 80% of them didn't register, right? That's when we, realized what could be the possible issues over there. So data science, although it is about coming up with insights, it's about coming up with meaningful insights, right? So you can't just come up with anything and say that this might you can't just give n number of vague answers. It's about being more precise about things, and this really helped us, and this is where data science actually helps for various other companies as well, not just on similar lines, but on various lines. This is just one example that I said, and this could possibly be considered as a case of lead generation. But yeah, I mean, there are so many things out there that could possibly, come up. I mean, where data science could be useful. So this was just one example. So ideally, now the reason why we actually went back to that data was because we had a hypothesis. Okay, and the hypothesis was we wanted to find out why people were not registering on our platform, why we had only 20 registrations in the first 1 hour for the Vidya Premier League. Using that hypothesis, we made sure that we had the data, and then we tried to back our hypothesis with this particular data that we had. So we went back to the data, did some analysis on the data, and this analysis that we did was something like where we plotted a few graphs, where we also went through a few metrics, some numbers. We came up with a few measures that we wanted to understand, uh, as to why people were dropping out and all of that. And then finally, we proved our hypothesis, as in like we figured out why people were not registering, right? So one thing that you need to appreciate about data science is that every hypothesis that you come up with need not be true. Okay, there is a very high case that a hypothesis that you come up with might be false or might not accurately work out, and you will honestly and most probably realize that only after you do all the analysis. So that's one thing about a data scientist. So you can never give up. So you need to make sure that you stick in, grind. You need to make sure that you grind every day. You need to make sure that you get your concepts on point. Okay. So you understand what the business is, and you try to come up with various hypotheses on a daily basis and try to prove or disprove them. A lot of times, yes, your hypothesis might be wrong, and in that case your entire experiment, your data science experiment goes wrong. I mean, like it might look meaningless, right? And it's fine, it's totally fine, because that kind of helps you understand what you shouldn't be doing or what doesn't really make sense for the business. So you could work on other things from the next time. So do not feel low if an experiment of yours does not get the results you're expecting, because that happens 99% of the times in data science. So do not worry much about that. Having said that, today we will be dealing with exploratory data analysis. And today's exploratory data analysis is going to be over a particular problem statement or a hypothesis, which will not give us the results that we will be expecting. Okay. So let's get started with it right away. I will be sharing my screen with all of you. So I'm assuming you are able to view my screen. So okay, so there is this really interesting concept. Just give me a moment. Let me try to reduce the size of, yeah. So this should be more appropriate. Yeah. Okay. So there is this really interesting concept for almost every business out there, and it's called the Net Promoter Score. Okay. In short, it's called NPS. Okay. So what is this NPS? A lot of times, I'm pretty sure you must have used a couple of products, probably services of Google or services of Facebook, probably an API. Probably you must have bought a product from some brand out there, and you must have received a feedback form, right? In the feedback form, there's this really seemingly unimportant question which pops up in the end, which is called, how likely are you to refer this particular brand, or tell about this particular brand to your friend or family member. Okay, that particular question constitutes something called the Net Promoter Score. So for the answer for that particular question, usually is a number between 0 to 10, which the user can choose. And the concept of Net Promoter Score says that the higher this particular Net Promoter Score is, the better your product is running in the market. So brands usually make sure that they so for example, if there's a company that's not really good at customer service, right? uh, Obviously, I mean, you're not going to feel like using that product. So if you don't feel like using that product, you're obviously not going to recommend that product to someone else, your friend, your relative, anyone, right? So the thing over here is that you need to, understand how many people out there are actually satisfied, how many people like your service, and how many people are willing to be ambassadors for your service, how many people are willing to promote your service, right? And that is what constitutes the net promoter score. So this was a definition of net promoter score, but let's look at the formula. Okay. So the formula of net promoter score is something like this. In short, it's basically the percentage of promoters minus the percentage of detractors. Okay, so promoters are those people who have very high regard for your product. So, for example, if for that particular question where someone says for that particular question where how likely are you to recommend this particular product or brand or company to a friend or family, if someone rates a 9 or 10 out of 10, then we can consider that particular person as a promoter. Okay, so anyone who rates the product, who rates who gives a rating of 9 or 10 for that particular question, the question being how likely are you to recommend this product to your friend or family. If the rating for that question is 9 or 10, that particular person is considered as a promoter. On the other hand, if the rating for that particular question lies between 0 to 6, or usually people have different ranges for this, so it's either 0 to 6 or 0 to 4. So we will be considering 0 to 4. So if the range lies between 0 to 4 for that particular question, then those people are considered as detractors. So detractors are essentially people who do not like your product, right? So you want to make so ideally you want to make sure that the number of promoters is 10 times higher than the number of detractors. Why? Because if someone likes your product, it's not necessary that they are going to recommend the product, okay, to someone else. But if someone does not like your product, very high chances that they're probably going to put up a post on Facebook or post on Twitter or some social media or the other. And that is going to have adverse impact because it's a social network and a lot of people are going to be able to see that. So once people form an impression about the product, the number of detractors will only keep increasing. So the effect that detractors have on a particular product or a particular product's, uh, you could say, a particular product's movement or success is much higher for the effect of a detractor is much higher in that case as compared to that of a promoter. So you want to make sure that ideally the number of promoters you have is much more than the number of detractors. Okay, and now we saw two ranges, 9 and 10 promoters, 0 to 4 is detractors. And then you have that middle portion, right, from 5 to 8. If anyone, falls in this 5 to 8 range, we consider them as neutral people. So these neutral people don't essentially have any bias or, any positive or negative bias towards the product. So they don't really affect the net promoter score. So we don't even consider them in this particular formula. So, ideally, net promoter score can be a value between minus 100 to plus 100. Okay. So the higher the value, the better is your net promoter score. So if your net promoter score is in the negatives, then clearly the number of detractors you have is much more than the number of promoters that you have. Right. And also at the same time, if your net promoter score is, on the higher side in the positive direction, it means that you have more promoters as compared to detractors. So the number of respondents essentially, so the formula is number of promoters minus number of detractors by number of respondents, the whole thing into 100. So it's basically a percentage that you'll be ending up with. So this number of respondents is basically the number of promoters plus the number of detractors plus the number of neutral people. Okay. So this is what net promoter score is. Okay. So now in today's project, what we're going to be looking at is whether so now if you have understanding about the stock market, you must understand that there's a huge value. I mean, the stock market is very fluctuates very often. right? And that's because people have different perceptions about the stock. And sometimes there's this huge part which comes under financial analysis, which is called sentiment analysis, right? So when you try to predict the price of a particular stock, you take into consideration the sentiment of how that particular company is performing. Like, for example, on various social media platforms, let's say we talk about a certain product. Okay. Now, if the perception about that product seems to be negative, or the company seems to be negative, then very high chances that the price of that particular stock is going to go down. On the other hand, if the price of the notion for that particular product, or that in that particular tweet or post, is positive, then high chances that more people are actually feeling confident about the product, which will make more people buy that particular stock, which will increase the price of that particular stock. Okay. So that's basically what net promoter score does. Okay, I mean, that's basically what we'll be dealing with. So what we'll be doing today is we'll be trying to understand whether the net promoter score has any correlation with the stock price movement. Okay, so ideally what it means is that we will be trying to compute a net promoter score on a particular day or over a series of days, and we'll try to see whether that net promoter score has some effect on the stock price on that particular day. So that's basically what we'll be dealing with today, and that is it is through this particular project that we'll also be going through certain aspects of exploratory data analysis. So let's get right into the project. Right. So we already have. So I've already shared the codes with all of you. So you must have received the codes from us. Yeah, if you haven't really noticed yet, I would request you to just go through the email that we sent it around 5:40 p.m. Just have a look at that, and you should find the codes over there. So this particular place where I've written code is called a Jupyter notebook. Okay, you can download the Jupyter notebook from the internet. All you need to do is just type Jupyter notebook download, and you are going to find versions for your particular system. So if you have a Mac, or if you have a Linux based system, or if you have a Windows system, you can download the right particular aspect for that. You can download the right particular software for your particular system. So we'll be going through Jupyter Notebooks itself. The reason being, Jupyter Notebooks is a much easier way to do analysis, exploratory data analysis, mainly because you do not need to run your entire code every time. So in case there's a particular part that I want to keep exploring with, then I can keep running only that particular part every now and then, and everything else remains the same. So it doesn't change the state of the other cells. So basically each of these rectangular boxes are called cells. Okay, so after every cell, if you are printing a particular outcome, or if you want a particular outcome, you will also see the output over here. And every cell, you will obviously write code within every cell, and you will find the outputs just below that. So it's very simple to use. I would suggest you people to actually use Jupyter Notebooks as well, because it just makes things very easy. So coming back to this, today we'll be working with purely just two libraries called Matplotlib and Pandas. Pandas, we already went through it in the last session. Matplotlib is a much it's a data visualization module in Python. Matplotlib essentially helps you plot various types of plots. For example, you can plot a pie chart, you can plot a bar graph, line plots, etc., etc. So we'll be using Matplotlib to just come up with a few plots here and there. For this particular data set, we already have the data. I haven't shared the data sets with you people. I will be sharing it once we're done with today's session. I'll be sharing it via email itself. So you can just use that particular data set and try to run the code as well. So let me just show you how the data set looks so that you get an understanding of it. So okay, so before we go on to it, let me tell you how exactly we are going to be calculating the net promoter score today. So the net promoter score that we're going to be calculating, we're going to be using user generated content for that. So what does that mean? So user-generated content is content generated by people all around the world. It could be on any platform. You could look at social media platforms. You could look at whatever you post on social media is basically user-generated content. On the other hand, when you go into a certain when you go into a certain e-commerce website like a Flipkart or an Amazon, you have reviews with respect to every product, right? So for I mean, like today, what we're going to do is we're going to use these e-commerce websites because we're going to be dealing with a particular brand called Hindustan Unilever. Okay. The reason we've picked this particular brand is because this brand has been listed in the National Stock Exchange for quite some time now, and they have a stock price which keeps fluctuating, right? So we have decided to go with this particular product, and also at the same time, it has enough user generated content on e-commerce websites, especially through in the format of reviews. So we'll be going through these reviews and ratings, okay, and we'll be trying to model our net promoter score through that. So let's just go to flipkart.com one. So we'll be using only flipkart.com for our calculation and analysis for today. So within flipkart.com, when I type something like SIF, okay, so SIF is basically a brand with respect to Hindustan Unilever itself. So Hindustan Unilever is a company. Within the company, you have multiple brands, right? So Hindustan Unilever has Sif, it has Ariel, it has Tresemme, it has Dove, it has Lakme. So it has a lot of different brands within which they again sell multiple types of products. So over here, Sif is a brand within Hindustan Unilever, and all these are products of SIF. So these variants that you see, all of these are products of SIF. Okay. So ideally, what we so if you notice over here, every product has a given set of ratings as well, right? So when you just go into a particular products page, you will also be able to look at the number of ratings. So 5-star, sorry. Yeah. So if you notice, we have 106 5-star ratings, 33 4-star ratings, 17 3-star, 2 2-star, and 7 1-star ratings. So we will be using these ratings today to compute our net promoter score. Okay. Now, net promoter score, if you remember, is usually calculated on a scale of 0 to 10, right? But the ratings we have over here are from 0 to 5. So what can we do about that? It's fairly simple. What we will be doing in this case is that we are going to be assuming only 5. So let's just divide the scale of 10 by 2. Okay. So we have 0 to 5. So instead of having two particular values that relate to a promoter, we will have only 5. So all those people who give a 5-star rating will be called as promoters. All those people who give a 4 and 3-star rating will be classified as neutral people, and those who give 2-star and 1-star ratings will be considered as detractors. Okay, so just try to expand this. It kind of correlates with our format. So since we have two values over here into 2, we get 0 the first 4 values. So that is 0 to 4 will be or 1 to 4 would be considered as detractors. So we have 2 values for neutral people on the scale of 5. So on the scale of 10, again we have 4 values, which is 5, 6, 7, and 8, because 5 to 8 is being considered as neutral people on the scale of 10. Over here we have only one particular value, which is 5, being considered as that of promoters, whereas on the scale of 10 we have 2 values, 9 and 10. So it kind of aligns with the actual scale. So we can stick to this particular approach. So we already have a data set where we have a list of brands and their products and all of that. One thing to note over here is that we are considering only those products of a particular brand that lie on the first page of Flipkart. Okay, so we are considering only these particular products that lie on the first page. So we're not going to the second page at all. So only those products that lie in the first page are being considered for calculating the net promoter score. So think about data science is that you always need to ensure that you define a few constraints here and there, and you are sure about those constraints, so that later you can actually revisit them to understand whether those constraints are necessary or not. So over here, one constraint that we had was that the ratings that we have on products on Flipkart is on a scale of 5. So what we did was we, shrunk the scale 10 scale by 2, and we made sure that we had, came up with the corresponding values for promoters, neutral people, and detractors. That's point number 1. Point number 2 is we have decided that we will only be considering the products on the first page of Flipkart to perform our analysis. Okay. So this is something that we have defined now. So we already have the data set ready with us. So we will be considering this particular data set that we have. So within this particular Hindustan Unilever, these are a few brands that we have. Okay, so we will not be considering any of these um, food and drink brands that lie within Hindustan Unilever, but we will be considering everything other than that. Okay, so we have Sif, Comfort, Active Wheel, Rin, Surf Excel, Vim, Axe, Dove, Lifebuoy, Lux, Pepsodent. So these are things that we use on a regular basis, right? So we'll be considering all these brands until Pureit. So basically, we'll be considering brands from Sif to Pureit. Okay. Yeah. So now we already have the data set ready with us, which is a great thing. So we'll be using this particular data set. And if you notice, the data set itself is stored in a particular format, right? So before we come to this particular format, let's see how we are actually converting it into that particular format. Okay. Now, yeah. So over here, every brand, uh, so we have about 7 columns over here. We have a brand column, a total column, and a rating column from 5, 4, 3, 2, 1, right? So within the brand column, obviously you'll have the names of the brands. Within what is this total column? So this total column is nothing but a sum of all the ratings that are available. So if you have, so in this case, let's take the first product of SIF. Okay. So over here we have 1 5-star rating, 1 4-star rating, 2 3-star ratings, 0 2-star ratings, and 1 1-star rating, right? So in this case, what we're doing is this total is nothing but a sum of these 5 columns, basically these 5 columns. Okay. So it's really simple. So this particular total is nothing but the total ratings for that particular product. Okay. So getting back to this. So the brand that we're considering is Hindustan Unilever. So it's called HUL. Uh, that's basically the short form. Even on the stock market, it's listed as HUL itself, Hindustan Unilever. And what we're doing is we are reading this particular CSV file that we have, the ratings file. Okay. I've just set a few variables to a dynamic term over here just because it makes things easier for us. Okay. So this particular ratings is stored within a folder called brands. Within the brand, I have a folder called HUL. Within HUL, I have a folder called ratings, and within that, I have a CSV file called this. So I'll just show you how it looks. I'm sorry. So this is the brands folder. I have the HUL folder, the ratings folder, and within the ratings folder, I have this particular CSV file. Okay, so we have read the CSV file. This read underscore CSV is a function which we use to read the CSV file, if you remember from last session. So this read underscore CSV is a function which is included within pandas itself to read CSV files. So over here, we are just defining few things called delimiter. Delimiter is nothing but what you're using to segregate columns. Over here, if you notice, every column is separated by a comma. So in case I use a hyphen over here to separate my columns, then the delimiter would be a hyphen. Okay, so delimiter is nothing but your separator, what is separating the columns of your particular file. And this is just an encoding. So I mean, I don't even need to put this. I've just put this because it just made me feel more confident about the code and the way it's being encoded and decoded. So that's about it. But you don't even need to mention these two things if you're reading a normal CSV file. Okay, I've just put it because it makes me feel a little more confident about the code. So we've read the CSV file and we've stored it in a variable called data. And then what we're doing is, we just want to look at what are the brands that are present. Okay, so what I do is I reference the brand column and convert it to a list. Okay, uh, so let me just show you. So this is the brands column, right? So I have one brand being repeated multiple times, right? But I just want to see, one particular occurrence of every brand, as in, like, I just want to see what all are the brands that I have within my data set. So for that, what I do is first I read the brand column from here. And for that, what I do, if you notice, is I say data of brand dot to list. So I've converted this column to a list as well. So I've read all the values from that column, and now that is what is stored over here in the format of a list. Now I say set of data of brand dot to list. So what does the set function do? It's actually a really interesting function. Uh, Sorry, just give me a moment. Okay, so we have this. So let's consider a list of this sort: 1, 1, 1, 2, 2, 3, 3, 3, 4, 4, 5, 5, 6, 7, 8. Okay. So ideally, if you notice, we have, so let's see how many elements we have. So we have 15 elements in this list. Okay. But the number of unique elements in this list are only 8, right? Because you have 1, 2, 3, 4, 5, 6, 7, 8. You have only 8 unique elements in the list. So now, if I want to get only the unique elements in the list, there's this function in Python which is called a set. Okay. So when I pass a list as an argument through this particular set function, which is an inbuilt function, I get something of this sort. So basically, it removes, it just, the set function takes an argument as takes a list as an argument and returns back only the unique values present within that particular list. So this function is a very useful function to see what all types of values you have within a particular list or a particular column, whatever it is. So yeah, it just gives you the particular occurrence. So that's what we're doing over here as well. So we want to just see what all brands we have, and then I'm again converting the set back to a list, which I don't need to do, but I have. Okay, and then I'm sorting this particular list. Okay, so I'm storing the result of this in a variable called brands, and I'm sorting that particular brands. Okay, so that is why I get to see all the brands that are present over here, and because I'm printing it over here, right? So I say print brands and I see all the brands that are present over here. Okay. Uh, Now what I want to do is I I basically want to make sure that over here, if you notice, we have had a particular brand. Okay, and then within the brand we have multiple products, right? And then over here, this column total is nothing but a sum of the particular 5-star, 4-star, 3-star, 2-star, 1-star ratings for that particular product, right? So this 5 is nothing but a sum of these 5 columns over here. This 22 is nothing but a sum of these 5 columns over here. This 4 is nothing but a sum of these 5 columns over here. Now, what I want to do is I don't just want it product wise, but I also want to see how many ratings do I have for every brand. Okay. So when I say how many ratings do I have for every brand, okay, what I need to do is I need to combine all these things together and find a sum. So basically the total number of ratings for SIF will be the total of all this total column. I mean, the sum of this total column until here. The number of 5-star ratings for SIF would be the sum of this 5-star column until here. The number of 4-star ratings for SIF would be the number of 4-star, would be the sum of this particular 4-star column until here, and similarly until 1-star. Now, I basically want to get a sense of that because, I just have a hunch. The hunch is that not every product is going to contribute to the net promoter score or the growth of a company as another product, right? For example, now let's take the example of Facebook itself. Okay, so Facebook owns Facebook itself. It has Instagram and it also owns WhatsApp, right? Obviously, Facebook is a pretty good product. That's how they started. But slowly, the number of people that they started having, number of active users that they had on the platform started decreasing, right? So now they primarily depend on other products like Instagram and WhatsApp, because WhatsApp, obviously, I mean, people use WhatsApp on a daily basis, right? And so do people use for Instagram. So it's the case with Instagram. So the usage of a particular product or a particular brand, okay, is not the same with even within a company itself, right? So every company might have multiple brands and every brand might have multiple products, and the movement of one brand might be more than the movement of another brand. In this case, as in the example that we took of Facebook, Instagram, and WhatsApp, evidently, I mean, WhatsApp should have more active users as compared to Instagram, which should have more active users as compared to Facebook in the current scenario, let's assume. So that's what we also want to understand. Okay, so we want to understand whether every product has an equal say to the movement of, or the perception of the company Hindustan Unilever. Okay, so what we're doing is, in pandas we have a function called group by. Okay, so we say data dot group by of a particular column. So whatever column you mention over here is the column that we're grouping by, and the column that we want to group by is a brand column, right? So we group it by brand, and then we just say these are the other columns that we want to have. Okay, and then we also call this sum function. Why do we call this particular sum function, right? The sum function is being called because we need to sum up all the values, right? We want to sum up all the values until for a particular brand, right, with respect to every product of that particular brand. So what that means is, we want to sum up this entire column until here, we want to sum up this entire column until here, we want to sum up this entire column, we want to sum up this entire column, all these columns until here for SIF, right? Similarly, for comfort, we want to sum it from here, 23rd row to the 31st row. Similarly, like that for all the products. So that's why we use a sum function, because the sum function helps us with respect to summing it for that particular brand. Since we're already grouping it by the brand, now we also want the sums of all the columns. Okay, and that is what we're doing here. So we are grouping it by brand, we are telling what are the other columns that we want, and then we are saying that give me the sum of these columns after you group this particular brand. So now if you notice, it gives me these results over here. Okay, so I'm just printing that particular outcome as well. So if you notice, this particular brand called Avians has 30 reviews. So let's just check it out. Let's go back here. Yeah, so Avians is over here. So it has 30 reviews in total, right? 14 plus 16 is 30. 5 plus 4 5-star ratings, is it true? 5 plus 4 5-star ratings, which makes it 9. 3 plus 1 4-star ratings, 4, right? And then similarly for all the other columns, so 4, 6, and 7. 4, 6, and 7. So yeah, I mean, we are able to achieve what we want. So now, as I mentioned in the very beginning of this particular session, data science is all about building a relationship and understanding the data in a way that is different from what most other people perceive it to be, right? So if you notice this particular total column over here, right, you have a brand like Avians which has only 30 review, 30 ratings, a brand like Axe which has 4,177 ratings. Then you have a brand like Lakme which has 1,51,379 ratings. And then you have a few other brands in 30,000 or 35,000, 15,000, 13,000, etc., etc. And on the other hand, we have a brand like Pepsodent, which which has just 5 ratings, right? So evidently, I mean, clearly over here, one thing we can notice is that not every brand affects the particular company's growth or perception as much as some other brand in that particular company itself. So for example, over here, what we could deduce is that Lakme is probably influencing the growth and outcome of Hindustan Unilever more than, let's say, a product like Hamam. Okay, because it has only 27 ratings, whereas this has 1,51,379 ratings. On the other hand, it could mean another thing as well. So, for example, if you notice products like Close Up, Hamam, Lifebuoy, uh, Pepsodent, so all these things, obviously, I mean, we know that these are products that we all buy because these are soaps and probably, yeah, I mean, these are soaps and all of that, right? Soaps and toothpaste and all of that. But why is this probably low over here? I mean, why do we have lesser values over here when we know that a lot of people are actually buying these things? One reason could probably be that people feel more comfortable going to kirana stores, or people feel more comfortable going to a supermarket and buying this rather than ordering it online. Okay. Also, at the same time, it could mean, I mean, like, it could mean one of the two things that we just mentioned. So either the growth of the product is more as compared, the growth of a particular company depends on a few brands particularly as compared to all the other brands within that particular company itself. That is insight number one. Or insight number two could possibly be what we just mentioned, saying that there are certain products people feel more comfortable to go to a supermarket or kirana store and buy rather than ordering it online. On the other hand, for example, Dove and I mean, Dove also is something that people go to a supermarket and buy, but let's say something like a Lakme, which produces cosmetics. Um, People, usually these cosmetics are available in supermarkets as well and all of that, but then probably people are just more comfortable sitting at home at their leisure, and it's probably more like a leisure buy, right? So we can't really come to a particular conclusion over here, but then since we are saying that our net promoter score that we're considering over here is basically based on the user generated content, for that reason, what we need to do is we need to make sure that we rely on the data that we have. Okay, so going by the data that we have, um, let's just try to plot out the total, this particular total column for every brand. Okay, and let's see what percentage it contributes to the sales or growth of a particular company. Okay, so we'll be using matplotlib for plotting. So in matplotlib, you have this function. Okay, you have a function called pie, which basically gives us a pie chart. Okay, and within the pie chart, what we're going to be doing is we're going to put in two things. One is the total. So total is nothing but this particular column that we have over here. Okay, so we're storing that in a variable called total over here, if you notice. So we say count by brands of total. Count by brands is basically where we are storing this particular data frame. So this entire thing is called a data frame. Okay, so this is something that we also spoke about in the last session. So this entire thing is called a data frame, and this data frame is something that is similar to something like a very primitive data structure, you could call it. Okay, not exactly, but just for the sake of intuition, try to consider it on those lines. So over here, what we're doing is to get the total, we are just using that particular data frame, and we're calling referencing a particular column which is total. Okay, and then we are also giving getting some labels, which is nothing but the brands. Okay, so ideally what I want to do is I want a pie chart. Okay, and within the pie chart I want to see what brand a particular set of the pie chart corresponds to. So I need the names of the brands as well, which I'm getting from my data frame itself. So I say plt dot pi of total labels equal to label. So these are nothing but just passing out your arguments. Okay. Now, what is this plt? So if you notice in the very beginning, we define import matplotlib.pyplot as plt. So this is nothing but just a short form for matplotlib.pyplot. So it's an alias. Okay. So instead of writing this entire thing, I'll just be referencing it as plt everywhere. So PLT is nothing but our matplotlib.pyplot. Okay. Uh, and then apart from that, I'm just storing everything else as well in various other variables to make things easier for me eventually. Okay. So let's not worry much about that right away, but we're just storing it. Like we're just referencing every other column and storing it in a different variable, like 5 star, 4 star, 3 star, 2 star, and 1 star. Okay. And then I'm plotting it. So plt.py of pi is a function within matplotlib.pyplot. So I'm passing the total, which is nothing but the count by branch part of total, that particular column, the total column in the data frame, the labels, which is nothing but the branch column in the data frame. And these are things that adjust the size of my pie chart, because I have a very limited space over here and I want my things to look clear. So I have just manipulated a few things here and there, and I've set these particular values over here. Okay. uh, so yeah, now let's and then I use this plt.show, because this is what will help me show my plot. Okay. So now this is the plot that we get. So if you notice over here, evidently 46.2% of this company's uh, products, 46.2% of the products being sold on Flipkart for Hindustan Unilever is from Lakme itself. Then we have another 11% from Vaseline. We have 8.9% from Tresemme. We have 12.6% from Dove, and we have 4.2% and 4.1% from Pond's and Sunsilk respectively. So these are probably the major chunks that we see, right? Sorry about that. So ideally, if you notice, 46 plus 12 plus 8 plus 11, so how much is it? 20, 66, 77, plus 4 plus 4, how much is it? 77 plus 85, 85 plus 0.9, 85.9 plus 0.1, 86. So we have about 87% of the whole pie chart, 87% of the products being sold on Flipkart coming just from about 1, 2, 3, 4, 5, 6, 6 brands. So if you notice, we have 30 brands in total. Okay. 30 brands in total. Okay. And out of these 30 brands, we have about just 6 brands corresponding to 85% or 87% of the sales of products for this particular company. Okay. So now this is something that comes under exploratory data analysis. Okay. Why does it come under exploratory data analysis? Because it gives you an insight into the company's performance on a particular place, right? So you understand your data, you're trying to figure out what your data does, and also at the same time you're trying to understand few insights. So you need not always build machine learning models, you need not build complex deep learning models and all of that to make predictions or derive insights with respect to data science. You can always do it purely through graphs and few other metrics itself as well. Okay. And this is just a very simple way of getting a few metrics over here. So this is also a part of EDA itself, exploratory data analysis. So we're trying to analyze our data in a much more detailed manner, right? So we haven't really built any machine learning model over here, right? So it's more of an EDA process or exploratory data analysis that we're performing over here. So we've noticed that about 87% of the sales of this particular company comes from just 6 products. So over here, one thing to notice is that everyone who buys a product on Flipkart or any e-commerce site is not certain to also rate the product. So we cannot directly call it sales, but let's assume it to be the sales. That's what we're saying. So this is an assumption that we're making. Okay. So we need to clearly define our assumptions at every state. Okay. Because these assumptions will either make or break your model. But even if it makes your model, great. You will obviously have to test what conditions it might fail under. If it doesn't make your model, you need to figure out what assumptions you need to fix. So always make sure that you define your assumptions carefully and properly. Okay. So yeah, we have seen that about just 6 brands correspond to 87% of the sales for this particular company. So now one thing to notice is that if 87% of the sales for a particular company is coming from 6 brands, then now if I have so this is a formula for net promoter score, right? So it says number of promoters minus number of detractors by the number of respondents into 100. Now, if I simply take this formula over here, what I'm going to be doing is this is more like an average formula, right? I mean, I'm just considering every product to every brand over here to have the same uh, influence on this particular company's growth. Okay, but clearly we can't do that, right? We can't do that because like you have so many products which correspond to 0%, 1.3%, or 0.2%, which is very minimal. But then on the other hand, so you have 24 brands, okay, which contribute to just 13% of the growth. I'm sorry. And at the same time, you have six brands which correspond to 87% of the growth of, or sales for this particular company. So that clearly says one thing, and that is we cannot go by the same formula which we have for net promoter score already. Okay, because that particular formula is more like a proper average. It's like just taking everything to have the same weightage, right? So now we have realized that okay, fine, these particular brands have more weight, or um, you know push the sales of this particular company more as compared to the other brands. So ideally, it means that the sales of these products should influence the growth or the sales of the company by a higher factor as compared to other products, right? So for that reason, what we can do is rather than taking the same formula as it is, okay, we can probably go with a different approach over here. And what is that approach? The approach would be to take a weighted average approach. Okay, so weighted average, you know how weighted averages work, right? So if you have three things belonging to one particular group and four things belonging to another particular group, okay, then what you could do is you're assigning a weight. Okay, so rather than taking just the sum of all these seven values and divide it by seven, what you're going to do is you're going to consider the sum of the values in that three values in that particular group and multiply it with 3 divided by 7. Okay, that's because you're assigning a weight of 3 by 7 to that particular group and a weight of 4 by 7 to the group which has four particular items. So yeah, so basically that's the approach that we will be adopting. And imagine, just imagine, if we hadn't plotted this graph, if we would have just gone by the numbers, or I mean, you can go by the numbers, right? So you went through the numbers, but we never really understood the impact of it, right? We realized that some products are obviously much higher as compared to the other products, but we weren't really in a position to make any assumption, or we were in a position to really model anything. But then when we put out this graph, it became very clear to us, right? Things became very clear. And that's one thing you need to remember. Okay, so if you're looking at becoming a data scientist, you need to make sure that one, you make the work easier for yourself, okay, and you're able to come up with insights in an easier manner. And two, you need to make sure that when you're explaining these insights to other people, it becomes easier. So tell me one thing, or just imagine, okay, we went through this particular table over here, right? Think about it. Were you able to understand the impact of all the products and total ratings over here more easily as compared to this particular graph that you have over here? Because over here, with respect to this particular table, you had to go through every number and you weren't really sure of the relativeness, or the relative status of every brand over here. But then over here with this particular graph, it became so clear. It was just so easy. I could just look at it and figure out, damn, okay, Lakme is contributing to almost 50% of the sales, right? So you need to make sure that you make things easier, not just for yourself, but for everyone around you. Okay. And also at the same time, imagine if we wouldn't have, put out this plot, we might have gone with the same formula of net promoter score rather than taking up a weighted average approach, right? Rather than even getting that, we wouldn't have even got that idea of, using weighted averages if we wouldn't have probably come out with this plot, right? So it's all about making sure that you understand what to plot, what metrics you need, what is your goal, okay? Because everything that you do, okay, should be aligning with the goal that you want to achieve. As I mentioned, yes, there are cases where you are not going to meet your goal, and that is totally fine, because data science is more like experimentation, right? And as a scientist, data scientist itself, right? So a scientist is someone who experiments, and every experiment of a scientist is not going to be a success. You're going to face 99 failures, but then you're going to come up with that one experiment which might make your life, right? So you need to make sure that you come up with various hypotheses, you come up with insights, and you need to make sure that it's at every step of the pipeline. Okay. So this exploratory data analysis also, I mean, you need to make sure that you understand your data at every line of code after writing every line of code. Okay. And that is the reason why I first put out this plot. So when I put out this table out here. So when I put out this table, I saw that okay, fine, there are a few brands over here which have more ratings as compared to others. So I thought maybe this particular maybe not all brands affect the growth of a company or sales of a company as compared to a few other brands within the company itself. So that was a hypothesis in within the project itself, within the experiment, right? And to prove that hypothesis, I decided to put out a few plots and just check out, and it became very evident because clearly if people are not really buying these products, why should I even really care about these products, right? At the same time, they are going to have a certain influence, but it won't be as high as influence as these brands have, right? Because end of the day, we're computing net promoter score with respect to user generated content. Now imagine going on to Flipkart and you see a product with lesser number of reviews. Are you really going to buy that product? Think about it. So whenever you're looking at getting into data science, just make sure you have some amount of domain knowledge and you think from the side of a particular person or a particular uh, the end user. Okay, when I say end user, it might be anyone. So in this particular aspect over here, in this particular project and experiment, our end user is a person buying a product. Okay, so a person buying a product is going to increase the sales of a company, and the sales is going to increase the growth of a company. The growth of a company is going to increase the stock price of the company, right? So these are things you need. Having some domain knowledge is always going to be helpful in data science. So make sure that before you directly dive into a particular project within a company, you understand the domain first. Okay. So, okay, fine. Now that we've realized that we have to go with the weighted averages approach, that's what we're going to do. Okay. So what I'm going to do first is, if you notice, okay, so we have one company. Okay, so let me just take out a particular image. Okay, so we have one particular company over here. Okay, so we have this one particular company, which is Hindustan Unilever. And within this company, we have multiple brands. We have Ariel, we have Surf Excel, we have Lakme, we have Tresemme, blah, 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 blah. So you have like 30 brands like that. Okay. And within these brands, you have user generated content from various websites, like, on Amazon, you have from Mouthshut, you have from Flipkart. But then over here, in this case, we're considering only Flipkart. Okay. So essentially over here, within every brand, you have multiple products. So you'll have for one product, you might get reviews from all these websites. From another product, you'll get websites from the same websites. From another product, you'll get websites, blah, and so on until all the products of that particular brand have been completed. Similarly for brand 2, okay. Similarly for brand 3 as well, and so on until brand N. So now, I remember when we went through in the beginning of the session, we decided we'll be dealing with brands from Hindustan Unilever. So our company is Hindustan Unilever. The brands, as I mentioned, are different brands like Sif, Ariel, Lakme, and Dove, Tresemme, etc. Right? Within these, again, you have multiple products, right? So what are the products? This is one product corresponding to Sif. This is every row over here is one product corresponding to that particular brand, right? So now, first, what we're going to do is, ideally, we have decided that we're going to be using the weighted averages approach, right? So even before we compute the entire company's net promoter score, first we need to start from a lower level, which is computing the net promoter score of every brand, right? Because every brand, as we already saw with respect to this particular plot, not every brand affects the sales or growth of a particular, or the perception of this particular company, right? these brands that primarily contribute to the growth and sales, sorry, are the brands that affect the NPS much more. Okay, or that's a hypothesis that we're coming up with. So over here, we need the weighted averages of these particular brands that need to be combined to form the company NPS. But then even before we go into getting the NPS of a particular brand, we need to find the NPS of a particular product, right? Because products, so we had a company, we had multiple brands, and within every brand, we had multiple products as well. So first, we need to go from a bottom to top approach over here, right? So every product is going to correspond is going to contribute to the NPS of a particular brand, and every brand in return will contribute to the NPS of the company. So end of the day, if you notice, every product is indirectly going to be corresponding to the NPS of the company itself, because we're taking a continuous path approach, right, from bottom to top. So what we're doing is, first we're going to be calculating the NPS of every product. So when it comes to NPS of every product is in itself one entity. Okay, you can't really combine it with any other entity. So over here, it's going to be a very simple way of finding the net promoter score, and we're just going to use this basic formula that we already have. So number of promoters minus number of detractors by number of respondents into 100. So that basically means that the number of 5-star ratings minus the sum of the number of 1-star and 2-star ratings, because 5-star ratings give us the promoters. Okay, then 1-star plus 2-star rating gives us the number of detractors. Okay, and the total number of respondents is nothing but 1-star, 2-star, 3-star, 4-star plus 5-star ratings. So these are things I'm defining over here itself. Okay, so 1-star, 1 underscore rating is nothing but um, so this is basically a function. Okay, a function is written in this format. So you say def space the name of the function, and within parenthesis you define the arguments of that function. So here I'm going to be passing an argument which is nothing but normal data frame. So when I say this, so what it means is that sorry, just give me a moment. Yeah. So when I say this, what it's going to do is that from this data frame, it's going to take 1-star, that particular column called 1-star, and convert it to a list and store it to 1 underscore rating. So I can just, over here, we are going to be passing a particular data frame, which is nothing but count by brands. Okay, count by brands. Okay. So we're just going to be passing that. Okay. So in that, if you notice, we already saw that we have 1-star, 2-star, 3-star, 4-star, and 5-star ratings, right? We're just going to be using those columns to, and storing those values over here in different variables. Now, what we're going to do is we are going to go through every product with every product within a particular brand and compute the NPS for every product. Okay. So we go through every product and all of that, and then we have these things over here. Okay, so we just calculate the number of promoters, number of detractors, the total content, and then we find the product NPS, and we append the product NPS into a list called NPS. So it's just we just define the NPS list over here in the beginning, and then we are appending this particular product underscore NPS value into this particular list. So that way we'll have a list of NPS for every product. Okay. So that is the way we'll be finding the product. The product NPS. Coming to the brand NPS, this is where things actually are very crucial, because we need to find the weight of every brand, right? So ideally, the weight of every brand is going to be the weight of every. So let me just show you if it's possible. Okay. So yeah, so this is basically the formula that we'll be using to find the particular brand's net promoter score. So coming to a particular brand's net promoter score, what we can do is that we have a net promoter score of every so every brand uh, is a combination of multiple products, right? And every product need not equally contribute to the growth of this particular brand. There might be a few products within this particular brand which correspond to the growth of the particular brand, right? So that is the reason why we're taking the weighted average approach. So this weight is nothing. So if you notice, this P capital PI is nothing but the net promoter score of that particular product, and PI is nothing but the number of ratings for that particular product, and this small PT is nothing but the total number of ratings for the entire brand. Or it's nothing but PT is nothing but P1 plus P2 plus P3 so on until PN. Okay, so yeah, that's basically the thing over there. So it just makes things easier. So that way we just we're just assigning a weight to every product's NPS, and we find the brand NPS. Similarly, like how we found the brand NPS, we are also going to find the NPS of the company. Just that over here, rather than taking individual products, we'll be taking brand and brand weights. Instead of taking product NPS and product weights, we'll be taking brand NPS and brand weights over here. So this BI is nothing but the NPS of a particular brand, and this beta I is nothing but the number of ratings cumulatively for that particular brand, and beta T is nothing but the total number of ratings for the entire brand. Okay, so I do understand. So this particular aspect that we're dealing with is more like trying to model a solution. Okay, so that's why I said today we'll in the email, if you went through the email, I mentioned that we'll be dealing with certain aspects of modeling without actually dealing with machine learning to make a predictive model. So this is not a predictive model per se, but we can actually extend it to be a predictive model without including machine learning algorithms. Because at the end of the day, every machine learning algorithm that you see out there, inbuilt machine learning algorithm, end of the day, each one of it is a combination of multiple mathematical equations. So similarly over here, we are also using math equations, but obviously there needs to be a lot more done to be able to extend this to become a predictive model. This is more of just a statistical modeling approach that you could call it. We're just trying to come up with the value for we're just trying to come up with a metric called NPS, and we are just modeling it in a way that we think is actually right, depending on the data that we have. So yeah, so as I mentioned, that's what we're going to be doing here. So first we find the we already have the NPS data over here for every product, right? So that's something that we already done through this particular function, that we will be doing through this particular function. And then we'll also have the number of ratings corresponding to every brand and every product and all of that within the data itself. So we just assign a weight, and then you multiply that weight with the NPS value for every brand. Okay, and that's how we find the brand NPS and company NPS as well. Similarly, we just find the weight and multiply it with the NPS and append it to a company NPS thing. So all these things are functions that we have defined, but we haven't really called these functions yet. So now first thing to do is call the functions out, and that's what we're going to be doing. So we're going to be storing, we're just going to again store a new data frame called, and we're going to be calling it data, and we're just going to store these 7 columns over here. And then additionally, what we're going to be doing is we're going to define a column called NPS, and we're going to add this particular NPS column with the values that we're getting from product underscore NPS of data. So if you notice, we are returning this NPS list, right? So when I'm returning something, the value is this particular function after it gets after it's run, and after it's being called and it runs completely, it's going to return the NPS list that we computed over here, right? And it's going to assign those values to a new column called NPS. And similarly, I'm just going to find the brand NPS as well, and then I'm going to finally I'm going to find the company NPS as well. So just to give you an insight into how the values look, you can have you can have a look at these things over here. So first, what we're printing is we're printing this particular aspect over here, the data of brand, total, and NPS. So this is nothing but that. So every brand has a total number of ratings, and then this is nothing but the product based ratings that we see over here. Okay, so over here the NPS of this particular first product that we see is 0. Why is it right? Let's just check. So this is the first product that we have. The first product's NPS is 0. Why is it 0? So what's the formula for a product NPS? The formula for a product NPS is nothing but the number of 5-star ratings minus the sum of the number of 1-star and 2-star ratings by the total number of ratings into 100. So the number of 5-star ratings is 1 over here, right? The number of 2-star plus 1-star ratings is 0 plus 1, which is 1. 1 minus 1 makes it 0, and total number of ratings is 5. So 0 by 5 into 100, which is obviously 0. So it shows that, our NPS is right, the formula is right, the function is working perfectly. So yeah, I mean, we have multiple products. We have about a total of 406 products, and we have an NPS associated with each of these products. So if you notice, we also have a few negative NPS scores, and it is possible because NPS is a value which lies between minus 100 to plus 100. Okay. So now this is nothing but the product based NPS. So next, let's try to print out the brand based NPS. Okay. So brand based NPS is this. So we have Avians, which has a total of 30 ratings, which is right, because if you remember in the very beginning, we saw the total number of ratings for every brand. And then it has an NPS of minus 13.33. And similarly, for all the 30 products, we have a thing over here, right? So we have a value over here, an NPS rating. Now, ideally, the value that we see, the final value that the company NPS that we get, should be really close to the NPS of Lakme, because Lakme contributes to majority of this particular company's growth or sales, right? And finally, we have also printed the company NPS, and it comes to 46.79, which is close to very, pretty close to the Lakme's NPS, right? So it clearly says that, okay, fine, I mean, like the functions are working perfectly, all right. But now that we've computed the NPS, okay, so I see something, I see a few questions over here. Um, okay, so Priyansh is asking which is better, data science or ML? I see that Shashank has already answered that. And honestly, see, the thing is, there's a very thin line between ML and data science. Okay. And it's just that data science, yeah, I mean, you do use ML within data science, and you obviously need to, understand your data to perform ML itself. So to be honest, there's a very thin line of difference. But then once you get into a company, you're going to see how the different, I mean, like you're going to see the magnitude of the difference with respect to the work. So while it's to be honest, both of them go in tandem, because uh, end of the day, when you're doing a data science project as well, your aim is to build a predictive model towards the end to make out the assumptions or insights that you've come up with and look at it from a futuristic perspective. Whereas machine learning, obviously you need to understand the data to figure out what model you want to use. So they definitely go hand in hand, uh, as Shashank has already mentioned. And yeah, Priyansh, we're also scraping the website. So there is a web scraping code that we have written. I will be sharing the web scraping code after the session. I just didn't want to share it before the session because it would have been confusing. So I will be sharing the uh, web scraping code and the data set itself after this particular session. Shaunak says that you can put data of call like that. So I'm not really sure which part you're referring to. So if you're talking about referencing a particular column by, that data frame of the name of the column, sure, yeah, I mean, you can do that definitely. So if you've noticed, I've just added this. So wherever I'm referencing it, I've just added this two list because I feel more comfortable working with lists. End of the day, working with a data frame type is also pretty much the same thing. So shouldn't be an issue. Okay, so we've computed the NPS now, but then our final goal is what? Our final goal is to figure out whether these NPS scores have any correlation with the stock price. Okay, and that is what I'm going to do. So for that, I'm going to import a module called NumPy, which is nothing but numerical Python. So it basically has a few really critical mathematical functions and uh, mathematical functions you can use, and that's what I'll be doing over here. So I've computed the NPS scores for 5 different days, which is 2nd July, 3rd July, 5th July, 8th July, and 9th July. Okay, and I've also taken out the stock prices for those 4 particular days. Okay, um, This is for HUL, and I also have data sets corresponding to all those days. So yeah, that's the thing. That's the reason why I've taken it for these particular days. That's how I was able to compute the NPS scores as well. Similarly, I've done it for the other. I mean, I've just taken out the stock prices from various websites. So I've just taken out the closing stock price. Now there's this function in NumPy called CORF, which is nothing but correlation coefficient. Okay. So in that, what I do is I just pass in two values and it gives me a correlation matrix. Okay. And this is the correlation matrix that I get. And over here, funnily, our assumption was that we are going to see a positive trend, right? We're going to see we ideally should have seen a positive correlation, okay, because that was the aim. So our aim was to figure out whether there exists a positive correlation through which the NPS scores can be taken as a metric or seen as a metric that affects stock prices, right? Over here we can see that NPS does affect the stock prices, but in a downward manner, which does not really make sense, to be honest, right? Because end of the day, if the sales are good, if the sales of a particular product are good, if Zaw, I'll be coming to your question in just a minute. So just give me like some time. So once we're done with this, I'll just be getting back to your question. Okay. Okay. So coming back to this. So yeah, it doesn't really align with our basic intuition, right? I mean, how is it possible if the growth of a particular product is good? So ideally, what the negative correlation is saying is that if the NPS is going high, the stock price will go low. Doesn't really make sense. So now we can't really come to a particular conclusion either over here, because what we have calculated the NPS for 5 particular days, right? So now thing about data science and anything is that you need to have abundance of data to make sense out of it, first of all. So we can't just go with the perception that we get after 5 particular days, but we need more data to actually arrive at a particular consensus, or to arrive at a particular insight over here. So yeah, I mean, as much as this particular thing might be true, we cannot say that it is definitely true. Okay. On the other hand, we have taken another stock called PNG. So there's this company called PNG, Procter and Gamble. So they also have a few stock. They also have a few products. They also have a few brands that they sell. And I've also computed the NPS score for them. Okay, because I also have the data for PNG. If you noticed, so I have data over here for PNG, but then I have it only for 3 particular days. So I just, jotted down for those 3 particular days over there. And I mean, I find the correlation coefficient for that. And funnily over here, I have a slightly positive correlation. I mean, it's very, small, but then there is some positive correlation, it says, which kind of obviously, again, it goes on the contrary with this, right? Because a slight positive correlation with a complete negative correlation is like, one end of the spectrum and the other end of the spectrum, not exactly, but in some sense of it. So I mean, yeah, there's not a lot we can actually infer from this in the end. Okay, so that's the reason, if you remember, in the very beginning of this particular session, I said that today we'll be looking at a particular example where we are not going to be arriving at a particular answer towards the end, because every experiment in data science need not give you the answer that you're looking for, right? So it might give you a wrong answer. I mean, it might give you an answer which is, sorry, completely different from the answer that you were expecting. It might give you an answer that's different from what you were expecting, probably because um, the hypothesis itself is wrong, or probably because you don't have enough data points to actually arrive at a particular insight. And over here, in this particular case, honestly, we cannot arrive at any particular insight because of the lack of data. Okay. So, two things over here: you need to make sure that you have enough data. Okay. And you need to be able to accept a result when it's not, coming out the way you want it to be. So, these are two things that you need to remember. So end of the day, this particular experiment that we did is basically inconclusive. So we can come to a conclusion for this particular experiment if and only if we probably have another, let's say, about 60 days of data. That's 2 months of data. That is when we can probably come up with a proper conclusive statement over here. Even then, we might not be able to. But then, yeah. So one possible reason why we might have got a negative correlation here is that there are some days where your stock prices go down drastically, right? Because of a few other factors and things like that. So the idea here is to just see whether NPS has some influence or not. Probably the timing that we chose over here was really bad for us. That might also be another reason why the uh, correlation is negative. And probably the timing that we chose for PNG is probably on, a slightly better side. So we can't really infer anything from just, about 3 days of data or 5 days of data. We need about at least, like, 2 months of data to actually make a proper conclusion over here. So yeah, this basically concludes what we've actually had to achieve in today's session. All the other things are, just some experiments which you can actually go through because you have the code. So this is, I mean, this is something really interesting. So, I think you'll really like it when you go through it, especially the last two parts, because it's more of an analysis of Flipkart alone. So yeah, I mean, just go through it at your leisure. It should be really interesting and fun as well. So this kind of concludes the content that I wanted to cover for today. And yes, I'll be more than happy to take up any questions if you have. So I see that Zaw has a question over here. Um, should I master all the algorithms to be a machine learning engineer? See, Zaw, the thing is that you need not master every algorithm because you can never be the master of all, right? It's really difficult. Instead, what I'd suggest is get strong in a few particular algorithms, but be in a position to understand the underlying math involved. Okay, so I mean, if you have a basic understanding of, you know, probability or stats and differential calculus and all of that, you would be in a pretty good position to actually tackle and understand any machine learning algorithm in depth. So if you're looking at becoming a machine learning engineer, definitely you will have to look at not just implementing algorithms but understanding these algorithms from within. So it's more about understanding the mathematical aspects involved. So yeah, I mean, I would definitely suggest that instead of mastering every single algorithm out there, uh, it's fine to master a few, but then be in a position to master anything by understand be by having a strong math background. So yeah, that should be something that I think answers your question. So any other questions, anyone? So somehow today, I mean, like, I expected to complete the session. I expected to complete the session in a short of time frame today. It's just that I didn't expected to complete it this early. But anyway, but how can convert a dot notebook? Okay, so what you can do is you have a couple of online tools, honestly. So you can do that, or what you can do is simply just copy paste notebook. And in case you want to extract a Jupyter notebook as a Python notebook, you can just go to File, Download as, and choose a particular aspect that you want to, um, download it as. So you can download it as a .html or a .ipython notebook or a .py notebook or anything. So you have various aspects over here. So you can choose to do one of them. So you have a few softwares online to actually convert a Python file into an IPython notebook. So yeah, you can do that. You're welcome, Vinay. You're welcome, Zaw. Okay. So anything else? Anyone? I mean, if you people have any further questions, please feel free to put them out in the chat section because we have quite some time. So I would be able to answer some questions if you do. And I mean, if you have no questions, Vinay, the homework task, we would be discussing it only via email. So the feedbacks that, in case you've submitted the task to us, uh, either you would have already got a feedback from us, or we will be giving you a feedback once the session is done. So we won't really be discussing the homework tasks or take home tasks within the live sessions. Sachin, so step by step in the sense, see, I mean, yeah, so first you collect the data, right? So data collection is obviously the first and most important step. So that's step one. Step two is obviously making sense out of your data, or exploring your data set, trying to understand what your data set is all about. So you need to obviously go through your data set, perform some exploratory data analysis, like get out a few metrics, try to understand what exists in your data set, how the columns in your data set are shaped. Um, Sorry, yeah, how the columns in your data set are shaped. Probably plot out a few graphs between a few columns, try to understand if one column is related to another column or not, all those things. So you do a basic exploratory data analysis. Once that's done, you try to figure out, like whether how you sit down and understand how you can achieve the goal that you want. Okay, so now you might be directly willing to build a machine learning model, but even if you decide to build a machine learning model, you decide what features are you going to include. Okay, what is the outcome that you want from that, and do you have all the features that you want into your model already, or do you need to build a few features? Like for example, over here we had, before we computed the company NPS score, we had to compute a product NPS, then compute a brand NPS, then finally we computed the company NPS, right? So it need not always be necessary that you always have the features in the data set itself. So you might have to build your own features as well. So that's that again, you have a separate so you have a separate aspect called feature engineering. So that's something that you might want to do sometimes. And then finally, you go through your you figure out what model you want to use, probably experiment with a few predictive models, or you might come up with a basic quantitative model itself to um, um, to actually make some predictions for the hypothesis that you've come up with. And finally, you have a proper prediction pipeline. So you just make the predictions and probably figure out whether it aligns with the hypothesis that you've come up with or not. So yeah, I mean, these are steps involved. So even before the data collection pipeline, I mean, like, you need to first define a particular hypothesis. So hypothesis is more like a line of the experiment. So what exactly do you want to perform your experiment on? So if you're not clear about that, you're never going to be clear about anything else. So make sure that you define your um hypothesis, and then start working on everything else. And within the exploratory data analysis part, the model framing part, and all of that, make sure that you define a few assumptions, because it's not practically possible to include everything into one particular model, or into an exploratory data analysis step. So there might be a few constraints that you might have, so you can mention those constraints. So make sure that you operate within those constraints only. Okay, and consider data only within those constraints. So make sure that you define your assumptions and constraints, because that's really going to help you a lot. So I mean, yeah, so hypothesis, data collection, exploratory data analysis, feature engineering, building a predictive model or a quantitative model depending on the requirement, and finally the predictions itself. So I mean, this kind of forms the pipeline. So I hope that answers your question, Sachin. Uh, be a little patient. We'll be coming to that in one of the future sessions. So we have 3 more sessions to go, right? So we will be coming to that in one of the probably in the fourth session. Yes, we'll be coming to that in the fourth day of the workshop. So tomorrow again, we will be dealing with some aspects of exploratory data analysis, and probably a little bit of modeling the solutions, probably a little bit of feature engineering as well. Um, yeah, and then after that, we'll be dealing with quantitative models and finally predictive models. You're welcome. You're welcome, Sachin. Okay. Okay. So as you already know, we do not have a session tomorrow. So tomorrow, instead, you will have a take-home task. So what? So for tomorrow's task, what you're supposed to do is, now that you have an understanding of this particular way of doing some exploratory data analysis and all. I would expect you people to also work on a few other plots Okay, so obviously we just have one particular plot over here, which kind of gave us some inference on things. But then there are a few other plots that you can come up with. Okay, I'm not going to tell you what exactly those plots are, but think about plots in the terms of line plots, in terms of bar plots, and things like that. Try to figure out a few plots that you think could actually make a difference over here. Okay, that you think might actually help us, relate, or uh, that might help us get a better sense of the hypothesis that we formed. Okay, so try to build out a few more plots over here and reason why you have built those plots. Okay, so you already have the code for this, so you can just work over this particular code that you have. But then wherever you add a line of code, I need a comment. So you can define comments in Python with a hash. So for example, I write a new line of code like a equal to 1 2 3. Okay, and then below that, I will mention why. I would want you to mention why you have written this line of code over here. Okay, so I mean, why are you doing this particular thing? Why are you doing this particular why are you plotting this particular plot? Okay, so I want a reason as well. So you have time until tomorrow 6 p.m. to actually complete this. So what sort of plots I'm expecting? Honestly, I do not have any expectations because I want you people to go creative. But end of the day, I do know that there are a few more plots that we can come up with than just the ones that we have already. So I would request you to probably just delve a little bit more deeper into the data set. I will also be sharing the data set, so that's not an issue. So I will be sharing the data set with you. I'll be sharing the data set for one particular day, which is 020719. So I'll be sharing this particular CSV file itself with you people. So you can just work on your plots and all of that. So all I want is for you people to come up with a few more plots, some more exploratory data analysis, or any other metrics as well. So not just plots. Feel free to use a few other metrics that you might want to come up with, and mention why you're coming up with those metrics, why you're plotting a particular plot. Vinay, I'm not sure. Okay, see, the thing is, I'm not sure what you mean by price because we do not have a price aspect over here. I mean, if you want to take it dynamically over here, what you can do is you can just turn this into a variable, right? So, but obviously you'll have to put this within a loop again. So, you'll have to make sure that you create a loop out of it, and accordingly you assign the dates to it. So this whole thing will have to come into a loop. So that way I mean, instead of changing the thing over here every time, instead of changing it to 020719, 030719, 040719, you can probably just write a for loop and uh, make things easier for you. But I'm not sure what you mean by price though, because we do not have a price column over here. So yeah, I hope I was able to answer your question. Okay, so any other questions, anyone? I mean, if you have no further questions, then okay, no issues, Vinay. Sure. Cool then. So, any other questions, anyone? In case you have no questions, please mention a no so that I also know that you have no further questions. Okay, so I mean, okay, what's the question, Sachin? I mean, if you have a question, please just put it forward. I mean, you need not wait, or you need not say that you have a question. Please feel free to put it forward. How have we taken NPS for different days? It's pretty much the same code. So let me just share back my screen again. Okay, so it's pretty much the same thing. It's just that we have created data sets for multiple days over here. Okay, so we have created data sets for multiple days, and then what we're doing is we're just changing this particular aspect over here and running the entire set of code again. So whenever I change the date over here, I'll have to run the entire set of code over here. And then once I find the NPS for a particular day, I just manually add it to this particular list over here, the NPS list. So as I keep running it for different days, I keep adding the NPS over here along with the stock prices. That's pretty much about it. So yeah, I mean, you just need to change the value over here to a particular date or a particular data set's name, and yeah, you can go through it. Okay, perfect. So I see that Zaw has no questions. So okay, cool. Um, okay, great, Sachin. Glad to hear that. Cool then. So any other questions? Anyone? Okay. So since I'm not receiving a response from anyone, okay, I see that Vinay and Sachin have also mentioned that they have no further questions. Cool then, perfect. So I'm assuming that you people have no further questions. In case you do, then anyway, we're going to be meeting again day after tomorrow, from 6 to 8 p.m. So yeah, we you can ask your questions at that time as well, because anyway we'll be dealing with exploratory data analysis again, a little more deeper aspects of EDA and feature engineering and all of that on Sunday. So that's pretty much it from my end, people. And thank you so much for joining the session today. I hope you were able to learn something out of this. And yes, make sure that you complete the tasks and send it through to us by 6 p.m. tomorrow on hello@vidya.org. And we'll send you the feedback. In case some of you have still not got feedback for your previous task, that's probably because you might have sent it a little late, probably after 5 p.m. today. So I'll be going through your tasks and I'll be sharing feedback very soon. So yeah, just stay a little patient on that. So thank you so much, people. Really appreciate you people joining the session, and I'll see you guys on Sunday. Thank you so much, people. Bye bye. Have a good night or a good day. See you.